Hey, welcome back. So in this third video, we're going to continue where we left off in the other videos. I want to start off by sort of going over some things that sometimes after you have something already built, you want to make a change to it. And I want to go over a couple of little tips and tricks that can sort of help this. And the first one I want to do is the board outline. So let's say we had this board outline. We have our tree here. And let's say we say, this stump is a little bit too narrow. I want to change the shape of this stump. But one of the problems is when we first created this board outline, we just selected the entire thing and then we defined that as the board shape and then we moved everything in there. But now all of these parts are inside the board. There's not really a good way to select, if we try to select the whole board outline like that, we're going to select all these parts too. So one thing we could, hold down Control and we could start clicking. It's a little tough to do. Hold on. So we could hold down Shift. Yeah, Shift click. We could Shift click multiple things and go all the way around the board. But that's a little tedious. So what we're going to do, I'm going to show you a quick way to, if your outline of your board is done in a weird mechanical layer, a mechanical layer that's not used elsewhere, one of the reasons we like to do that is because it makes it easy to change the board shape. So let's just say I think this tree trunk is a little bit too narrow. So maybe I say I want this tree to have a nice robust trunk. So what I'm going to do is I'm going to change the, I'm going to move this maybe here and move this, move this one here. Now I haven't actually changed the outline of the board. All I've done is I've changed the outline of the drawing that I originally made the board from. And the problem is right now it's tough to select all of these pieces of this drawing. But one thing I can do is I can click on part of it and then I can right click and go find similar objects. And this is the thing, if I had chosen a mechanical layer that's not used elsewhere, I can basically just say, find any part that is the same as mechanical 12, and I don't care if it's a track, it doesn't have to be a track, it can be a radius, it can be a circle, it can be any shape. But all I care about is I want to find everything that's a mechanical 12. And I'm going to click apply and OK. And what this did is it automatically selected everything that was because the only thing that was mechanical 12 was the outline of this board, it selected the whole board outline. So now I can go design, board shape, define from selected objects, boom. And now because I was able to easily select all of the outline of the board, it's easy to change the shape of the board itself. So that's a way to make a change there. Let's do another change. So let's say one thing that's pretty common is if we go back to our schematic. So this is great if our entire circuit works. If everything in our circuit works fine, this is a great way. Everything's going to go smoothly, it's fine. But a lot of times, especially if you're doing a prototype circuit, you realize fairly quickly that something's not working right. Or you're setting it up and all of a sudden you get a ton of current and something's wrong and something's broken. So normally if you're doing a prototype board, you're going to want to basically put a bunch of test points and a bunch of 0 ohm resistors. But if you're pretty sure the board's going to work and you just want to have an option just in case something goes wrong, there's something I like to do, and that is if we go to components and we go to miscellaneous devices, let's just pull a resistor. Let's pull a res 3. Again, make sure it's 0603. Place that. So what I'm going to do is I'm going to try to isolate the power side, the boost side of the circuit from the other side of the circuit. I'm going to try to completely isolate this. Let's do it after the switch. So basically, if I populate everything over here, or sorry, if I want to isolate the boost regulator from this part of the circuit. So if I have this and everything works fine, then I add this and something goes wrong and I want to disconnect it, one thing I can do is if I put this, it might not be a good way to make it work. Maybe I can put it right here. Well, here's what we'll do. We'll put it like this. And then we're going to draw a net. So we're going to put both sides of the resistor on this connector here. So both sides of the resistor are tied to the same signal. And then we're going to go Tools, Annotation, Annotate Schematic. Update the PCB. Now, let's see how we can use this. So now, both sides of this resistor are VBAT, and that's going to allow us to basically take anywhere in this chain where we have VBAT. So I'm just going to move something around a little bit here. Make a little bit more space here for this. Okay, that should be fine. So made a little space for this, and now what I can do is I can actually put this resistor right here. My grid is a little bit too coarse right now, so we're going to go back to a slightly finer grid, and I can actually put this. It's not going to quite fit. I'm going to move this a little bit more over. Not too far. That might work. Cleaning up some of this junk here. So what we can do is route a trace all the way through this thing. Okay, now why did I do this? Why did I put this resistor here in line with this thing? First of all, let's check the 3D view. Let's escape, hit 3 to check the 3D view. So now we've got a resistor here, and what's important to note is that where this resistor is, underneath this resistor are two exposed copper pads. So what's going to happen here is normally this resistor is going to be a resistor that we don't populate. So normally we don't have to put anything here. We just have a wire going straight across here. But if something goes wrong with this part of the circuit, what this allows us to do is we can come in with a razor blade and we can cut this right down the middle. We can cut this down the middle, and then if after we get our thing, after we've isolated it and figured out what's wrong, we can now piece this back together. So we could either jumper solder over here or jumper a 0 ohm resistor over here. And this just gives us a little bit of a tool to break a part of our circuit away from another part of our circuit and then reconnect it after we're done prototyping it. And ultimately, you can take this out. If your design works and you're done with it and you don't need this, you can take it out later. But it's kind of nice to have these at certain places in your circuit. These are kind of like a cut trace. A cut trace is a part that's specifically meant to be cut to give you the option to cut it. This isn't, the main difference being a cut trace is actually going to expose the metal here. Although if you're cutting copper with a razor blade, it's going to go right through the solder mask anyway. So it's just a little tool for prototyping for us to just do this trick. And it doesn't really change much. It just sort of gives us, mostly again, it just gives us these copper pads underneath here. Now we want to specify, it's a little weird to put this in the design. So one thing we like to do with these usually is, I'm going to put, for the value here, I'm going to put DNP. So I'm just going to say, basically this is just an indicator looking at this schematic that you shouldn't populate this, right? This is just a footprint that's there for our use. Maybe we need to populate it if we end up doing something, but it tells whoever's assembling this, look, you're not going to actually be putting something there when you actually build the board. Okay, and we can leave that in there and that's all fine. So let's go back to our board. So we have now the USB connector going to the charge regulator, the battery connection. We have the boost converter here. There's not a whole lot of room left on my board, and this is a time when maybe if I was really running out of space, I might take this boost converter and move it off to the side. I might kind of try to squeeze it in here to make a little more space. I think I'm going to be fine though. I think I'm going to be able to get my design in here just fine. But the thing is, one thing to note is we have sort of a sequence of connections. We have VBus to VBAT, VBAT to the boosted signal coming out here. And our ground path is a ground path all the way down here. And normally we would probably make this ground path a nice fat ground plane to really, we really like to minimize the resistance on that ground path there. But this circuit that I'm building, it's not a huge concern. It's not a huge size issue, so I'm not going to worry too much about it. But the main thing is our power inlet's over here. Our power outlet is right here. So this is really all we have to connect to our final op-amp circuit is going to be this right here. So let's look at what our final op-amp circuit is. So my design for this final op-amp circuit, I want to build basically two of these circuits. So what I have is the design for my design is going to have two thermistors on the corner of the tree. And when you put your thumb on the thermistor and warm that thermistor up, it should turn on a certain color of LEDs on the tree. So basically what we have is we have a voltage divider here. This is going to be an NTC thermistor. So as the temperature goes up, the voltage at this terminal of the divider is going to go up. So this voltage is going to increase. We're using a difference amplifier topology so that we can subtract out that offset of this. So we can, this voltage is going to increase. We can subtract off the baseline voltage. So this output signal is just going to be that marginal voltage gain. And then this feeds into a voltage to current converter where the voltage to current conversion is the ratio of this voltage applied to the pin divided by this resistance of this resistor. So essentially to choose the voltage to current gain, we're going to change this resistor value. For this design, the values here don't matter. That's not the part that I care about. Ultimately, for your design, you're going to want to put your actual resistor values. I'm just going to build this thing with just generic resistors and not worry about the calculations for right now. So let's start doing that. So let's look at the op-amp design, right? We're going to need, so I'm going to build two of these. So this is going to be like on the left side of the chip, and it's going to drive one color light, and then I'm going to have one on the right side of the chip that's going to drive another color of light. So each one's going to take 2 op-amps. There's 2 op-amps on one physical chip with the chips we're using, so we're going to need 2 physical chips. Let's go back to Altium, and let's start piecing that together. So I don't like to, this is already pretty cluttered up here, and actually probably just so it's not all crowded on the side there, I probably want to just kind of space this out a little bit. I'm going to do my op-amp design down here, just give it a little bit more space. And usually this is probably a little too crowded. Normally you'd want to segment. The USB connector could be one section, the battery charger could be another, the boost converter could be another. Usually you break them apart. I did it all in one just to show how they're physically connected, but normally, as long as you're using these net labels, you don't have to actually have the wires be physically connected. So now let's look at our op-amps. So if we go to components and 320 parts, our op-amp is going to be but I have trouble reading these things. LM358. Let's place one of these. Let's do one here and one here, and then we'll do another set of op-amps down here. So then we'll do one here and one. Try to keep them kind of the same a little bit here. One here. Okay. So we have 4 op-amps. That's going to be the 4 op-amps we end up having in our design. And let's just go ahead and populate this design we've got right here. So the first thing is on this positive rail, we have this thermistor resistor divider. And I might want the ability to tune this. So if I want the ability to actually tune this, I probably will want to put a potentiometer here, like a tunable pot here, just in the middle, so that I can sort of shift this ratio a little bit if I need to help this thing out. So I might tweak the design a little bit. So let's place, first of all, let's get these thermistors down here. So to find the thermistors, if I look at the data sheets, oops. So if I look at the data sheets here, NTC thermistor. So these are, again, lots of Chinese. Pretty sure these are said 0805. So 0805 10K NTC thermistor. So that's mainly what we care about. So let's look for 0805 thermistor just to see if we get lucky. Look at that. We got a nice 0805 thermistor. And again, we have multiple footprints that we can choose from. So I'm almost always going to go find the footprint that is the lowest density. So this is the highest density. This is the next highest. This one's definitely the lowest density one. So, so I'm going to place this part with that low density footprint if it eventually pops back. So this is going to be our thermistor. It looks just like a resistor, but is labeled RT. So space bar. So I'm going to plop that. We don't have to crowd it too much. I'm going to put it here-ish on this side, here-ish on this side. Okay, so we got our thermistors down here. Another thing to note with the footprints, one thing you can do is if after you've placed a part you want to change the footprint, you can go in here and, oh, we actually had the wrong size selected. So I guess, yeah. So we're going to choose this footprint for this. And for this one, we're going to choose, oh yeah, so we already had the big footprint for that one. Big footprint for that one, okay. So if you've already done that, we might have some other parts we want to sort of look at then. I might have done some of these wrong, so I might have thought I was selecting a certain footprint when I wasn't. So, and one thing to note though, if you change the footprint, next time you reconnect, it's going to kind of throw things off a little bit. But anyway, but you can always go back and change the footprint. If you have multiple footprints associated with a part, you can change it by actually looking at the part properties itself. So now I also wanted a pot in the middle here. So we can go to components. I think I had a surface mount. So yeah, surface mount potentiometer here. So let's place that. Space bar to rotate. Put it, oh, look how perfectly that lined up there. Ooh, sometimes you get lucky. And then on the bottom side, we'll just put an 0603 resistor. So components, miscellaneous devices. And look, we already got that. And you know what? We might as well place a bunch of these resistors. So we have a lot of resistors we're going to have to place here. So we should have our feedback resistor. We're going to have a feedback resistor to ground up here. Put that here. We've got our offset resistor here too. Okay, I think that's, let's go back and look at this. I think we got them all. All right, so let's start hooking up nets to this. Let's get our grounds in here. Ground. This one's got to be grounded. Okay, and we gotta have our 5 volts VCC here, 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 oh, and the op amps. So one thing to note is we show 2 physical op amps. These 2 physical op amps are both the same, basically they're 2 parts on the same package. So you'll see pins 4 and 8 are labeled the same. So I don't think we actually need to put labels on both of these. They just have to be consistent. So, and I'm not even sure that's the case. I've never really tried it. So. So I think we're, oh yeah, we gotta put rails over here too. Okay. Now we do need LEDs too. So we're gonna have to have, so these are gonna drive LEDs. Maybe I wanna put a couple actually. I'll put a couple in parallel here. So, so we go to 320 parts, LED red. Let's place some of these LEDs. So the LEDs are in the feedback path for these. And I'll put a couple here. It's getting a little crowded there, but it'll be fine. Anytime I put LEDs in parallel, I always like to have at least a little resistance. So I'm just going to do our little shift click option here. And again, I'm doing this because this is not annotated yet. If this were annotated, the shift click kind of becomes a pain. But because it's not annotated, the shift click should work out just fine. Okay, now let's start connecting wires up. So again, I hope these videos are really just for your benefit, and I don't know how you use them, so feel free to fast forward when I'm doing boring stuff like this. And feel free to mute me if you don't like me talking, or just go ahead and fast forward too. Sometimes I go too slow, so I'm not known for moving quickly with these things. So let's do. That could have been done a little bit better. That one up a little. That's all right. Nobody knows. You're not going to tell anybody, are you? And we got to do this. And that looks pretty good. I don't see any issue with this. So again, I should be labeling these resistor values here with my actual values, but for now, I don't care. For this design, I'm not. The goal of this is not to show you the specific results here. So it's not to show you the actual specific op-amp design. It's to show you the assembly process. So let's just annotate this thing. So this is one area where the annotations being sort of, the order of annotation can matter a lot. So you'll look, I think I had it set when it annotated, it went from left to right and then down. So it annotated in the order like reading a book. So you can see R10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is actually going to help us. Annotating in this order is going to help us actually build these physical circuits. It should make it a lot easier to actually make these connections. So, because we can, if we just lay them out the same way this is done, then the order number should be pretty good. So let's go back to our board, and yeah, first thing I like to do is just move them all a little bit closer here. So. Okay, so one thing I said is my LEDs, I want these to be on the other side of the board. So, right now I can probably just take all my LEDs. So I'm just going to select all those LEDs, and I'm just going to go flip selection. And so I'm just going to put them on the back of the board, and I'm going to put them off to the side for now because I'm not too worried about them. Ultimately, I'm going to decorate my tree with these things, and the connections to the LEDs is not really what I care about right now. What I care about mostly is getting these op-amp circuits looking good. So maybe what I'll do is I might do one op-amp circuit sort of down here, and I might kind of have it be a rotated circuit. And then I'll probably do a similar op-amp circuit over on the other side. So let's just assemble one over here. So this was op-amp U4, and op-amp U4 is these ones down here, but it doesn't really matter. The main thing is if it's op-amp U4, we want resistors R17 and up. So we want to use resistors R17 and up. So R4, we should have an R17 here-ish, an R18, R19. Let's see, 19, 20, and 21 were over on this side. So, and sometimes they're even kind of flipped here. So, okay, we got our thermistor here and our potentiometer here. So now that I have these sort of where they need to go, I'm going to zoom in and see actually how best to flip these things around. So what do I care about? I care about where my power and grounds are. I care about where these resistors connect. So I'm going to really quickly see, let's just start to kind of see what's going to be the best way to sort these out. That one looks like it's going to be good, like that. And sometimes these annotations get in the way a little bit. Actually, the VCC we probably want to keep on this side. There, that's looking good. This variable, this potentiometer here. We got a little cross action here. I'm going to flip it a little. Looks better. And should be good. So now also keep in mind though, this is my thermistor. So actually I kind of want my thermistor to be on the other side too, because my thermistor is going to be on the surface of the board that you touch with your finger. So I'm going to take this part, I'm going to do edit, move, flip selection. And so now it's on the back side of the board. And ultimately we're going to have to route through to get to this thing, but again, I'm not too worried about it. Put it kind of a little closer to the edge here. And again, just so we can see what that looks like, if we hit the 3 key, let's look. Right, so we got all these parts on the surface here, and that thermistor now is going to be on the bottom corner of our tree. Okay. I'm having real trouble rotating in this video. Kind of not very coordinated, I guess. Hit the 2 key, go back to 2dV. Let's finish up these resistors here. So we got 19. R20 here. It's 42. That's going to be okay. What's this R23 hanging out here? What was R23? Okay, R23 is this little straggler's got to go back down over here. Perfect. Perfect. Looking good. Okay. So just before we get too far into this, let's just route this little section, because basically if what I get here works out pretty well for me, I'll probably just copy this design for the other side. So there's no reason to crowd this thing too much. We're not that hurting for space that we got to crowd this thing too much. Let's space things out a little bit. Again, we can check the 3D view, make sure it looks like we're actually going to be able to assemble this. And let's start connecting these things together. So most of this, the VCC and ground are going to be high current, but most of the rest of this is not stuff we got to worry too much about in terms of it's not too high a current. So let's start connecting it up. Okay, so what's happening is I clicked this and its default size was way too wide for this to actually be able to route. So it's kind of showing this little, it's kind of wigging out on me a little bit here. Let's hit the tab key and change this width. We're in millimeters still, so actually probably the first thing I'm going to do is go back to, so I'm going to hit the Q key and go back to mils, and then I'll probably check my grid to make sure my grid's not something wonky. It's probably good enough. We'll hit tab. So the width is set to 28 mils, so let's just set this to like 12 mil. See how that looks. Much better. And then my routing style, I don't like that routing style, so I'm going to hit shift spacebar. That's more like what I like here. There we go. Okay. Again, we're just going to start routing this together. Click that little connection. Across the chip here. I'm going to set my grid a little bit finer here. It's kind of not liking the coarse grid right now. Alrighty, let's do. So again, please feel free to fast forward me. I won't take offense. That was kind of ugly. So it was routing ugly because my grid's a little, my grid probably is, these are smaller parts and my grid's probably a little too fine for these parts that are here right now. So this pad connects to the thermistor, so it's going to have to punch over the other side. This one's our ground, which is currently kind of thick here, which is fine. It's not necessary for it to be that thick. All right, so these connections are going to have to punch underneath eventually, but for right now, let's get to that ground bar down there. So let's pluck our ground here. And move this thing around the trees. We're just going to wrap all the way around this one. Perfect, right? So that's a fairly low resistance. That's a pretty good connection to ground. And then the other thing we got is we got the VCC. Some point connection to VCC here. That should work. And what I'm going to do is let's finish up this video by just cleaning up this annotation a little bit. Actually, for right now, these annotations are a little bit too big. So I'm going to click on one, right click it, and go find similar objects. And I'm going to make sure all designators text the same. So I'm going to select every single one of these annotations. And then when I do that, it pops up this sort of editor here. I'm going to make, it doesn't have to be 60 mils high. These can be 30 mils. And their width can be 6 mil. And I much prefer that. Did it change them? Change it. I don't know what I did wrong. Oops. Yeah. Okay. Now I'll edit it in properties here, I guess. So text height 30 mil. Text stroke width 6 mil. Okay. You know what? Let's go 40. Maybe a little too small. And maybe make this 8. Okay. Much better size for these things now. So I'm just going to clean up this bottom corner, and then what I'll do is I will, after we get this annotation cleaned up, I will magic of television this and do the other side, and then we'll come back with another video. So, oops. Not great. I should probably spend a little more time getting this alignment kind of a little more even. Sometimes I set the grid a little bit more coarse, but you can see that looks a whole lot better. If we hit the 3D view, much better. It's very easy to see which part is which. You can't see the U4 here, but that's because the part's covering it. When you're actually assembling this, you would see the U4. If you want to move that off to the side so it's more visible, of course, you can always do that too. So we could do it like that so that now we can see every single part. Okay, that's good enough for now. So what I'll do offline is I'm going to just replicate this exact process we did on this side. I'm going to do it with the other part, and then we'll come back and we'll finish up. I'll talk a little bit about moving these LEDs, doing auto routing, and then finishing up and setting this board up for fabrication. So when we come back, that's what we're going to do. Thanks for watching. Smash that like button.